Hello guys, welcome to my second tutorial. In this video I will show you how to approach rendering an interior scene. I am using Octane Render version 3, but it will work also for version 2, and every link what I mentioned in this video is in the description below the video. So let me first show you what we are going to do today. Ta-da! It doesn't look very nice and it's full of noise, and this is what you get with default settings of path tracing kernel in Octane and with not so good HDRI map or light map. I would call it light map because it's much easier to say. Now this image, if we can say that this image was rendered in 1 minute and 3 seconds, and it was rendered with 1024 samples, and the dimensions for it are 1024 by 512 pixels. Now I am using two GPUs, GeForce GTX 780 Ti with 3 GB of RAM each, and well, it doesn't look too good, as you can see. Now let me show you what we can make out of it. Ta-da! Now you must admit that looks amazing. How big is the difference between good settings and good light map? Now what's even better is that this image is exactly the same size. It's also the 1024 samples, and it rendered in 30 seconds, and you can actually see what's going on in the scene in comparison to this festival of noise. Now let me show you how to get to this quality with some specific steps you have to take. Okay, so I'm using, for this tutorial I'm using the Octane standalone version 3, and it works, everything that you will see in this video works exactly the same in the plugin version, but I'm using a standalone because you probably if you have plugin, you probably have the standalone version, and the second is that the standalone version is a little bit faster, I think, and it's more responsive, so it's better to work with, and it has a node system that comes in handy. So what you see here is Rhino, because I'm using Rhino. I have the Octane for Rhino, but I will use standalone, as I said before. Now I have this interior I created. It's very simple model, as you can see. Now first thing that you should consider while creating some interior scene is that you should always model, if not the whole apartment, then at least the whole room, because when the lights comes in through the windows or other holes, it can hit the wall and it gives the specific shading that we all are used to, so it improves the quality and the realism of your final image, so keep that in mind. And another thing is that, as you can see here, I have some furniture, which is some table, couch, some armchair, etc. And well, I modeled this apartment pretty quickly, but modeling furniture can be time consuming and pretty much complicated, so the best way is to download it, so you don't have to model furniture anymore, because there is such a great site called Google SketchUp Warehouse, and it looks like this. This is the address. It's 3dwarehouse.sketchup.com, and it's a huge library of many things, from vehicles to furniture to buildings. As you can see, it's some great bike here, houses, well, you name it. and you can find almost anything you need, if not everything, and the quality usually is pretty good, and you can preview the model directly on the web in your browser to inspect it. And as I said, the quality is pretty good. As you can see, this chair looks okay, so you would spend some hours to model it, but you have it in a couple of minutes. Now the website itself won't help you unless you download the free version of SketchUp, which is called SketchUp Make. So go to sketchup.com/download and just select the personal projects, fill out this form, and you can download the SketchUp Make. Now what's tricky in SketchUp Make is that it won't allow you to export the geometry to the OBJ format. You can only export to the DEA or KMZ, which I think won't help you much in this case, but you can download the free extension that lets you export to STL file, and Rhino can import STL file. And I know that there is an extension for Blender, so you can import that in Blender too. And if you want, you can export. Blender is a free software, of course. You can export from Blender to OBJ file if you want. Now the STL file is a simple mesh file without any textures or materials assigned. For me it's not a problem because I usually do my own mapping in the Rhino. Now let me show you how it works. So I open my file, and this is the chair we were looking before. Now selected, I have the extension installed. You press the export, choose your desired units. This I believe doesn't matter, I leave it as a default ASCII. Now export STL file, save. Now I go to the Rhino. Here it is, my file. Okay, STL models, centimeters. I'm using centimeters in my scene. As you can see, I'm leaving a little bit of room between the chair and the floor, so I have that little gap, and you can see it on the renders. In a way, it forms the black line, which adds some realism. Well, I very often see images that don't have this line, like the objects intersects or touch the other surface, so it's unrealistic. You should always have some room. Half a millimeter even is okay, or even less. Now as you can see, I imported it. It looks okay. I don't even have to modify anything in it, so the only thing I need to do is to apply my material to it. So, and that's some important part. If you want to export your scene to Octane Render, you have to assign materials to all your geometry. If you don't assign material to your geometry, Octane will assign the default material. Now if you don't assign, let's say you assign material for everything except the wall and the ceiling, then those two objects will be treated as one, and the thing that keep them in as a whole will be this default material. So everything without material will be one object with default material in Octane. And as you can see, I have assigned materials. So if I want to have the ceiling as a separate object in Octane, I assign the material just for the ceiling. And of course you have to name every material with the unique name, and because so the Octane can differentiate those materials in while you use it. Now I have to assign the material for my chair. Now as you can see, let me just ungroup it. and I will make this some yellow chair. I'm just naming it so I know what to look for in Octane, and this will be black. As you can see, there's normals are reversed, but I don't care at this moment. I think this thing could have been done better, but it doesn't matter right now. I just group it and let me just create new material. Not this way. There we go. Like this one, I will call it black, and assign it to your geometry. If you don't assign it, it doesn't matter if you create it or not. Oh, here are some little guys, so let me just add them to the group and all like this. Okay. Now what's important is how you name your materials. Of course, it depends from your personal preferences, but you can name them by the object you assign the material to. Like I have here, like floors, walls, window, portal, tiles, etc. And if you are planning to use that material only for that one object, that's fine. But if you want to use, let's say, material that's called floors, and the floors will be black, and you want also the chair and the table black, and you will create some confusion. So maybe you should try naming the materials by actual material that it is, like chrome, wood, plastic, etc. So now we can, if you have material that is called chrome, you can assign it to everything that is chrome, and I have it like here. As you can see, this and this is, and this, those two objects have the same material that's called chrome, and this is logically organized. So if you keep everything logically organized, it will speed up your workflow pretty much. Now, one more thing is that I'm using this geometry as a portal, so it will help render my interior scene. What the hell is that? This is a door. Okay. Now, the idea behind the using the portal is that it should seal your scene, your interior, so the light rays don't fly away. So the whole calculation will be done in this cube, we could say, because the windows and the doors, actually there are doors, but the windows, every hole in the wall is the place where the rays could escape, and you have to hold them inside. So from the top and from the bottom is the floor and the ceiling that holds them up, but from the windows we don't have anything. And if you put some materials that are transparent, that would serve as a glass material, so the rays still can escape because it's transparent material. And the portals, even if the portal is also transparent, but it keeps them inside, and thus this should speed up your render. Well, it depends on the scene itself, and I will talk about it while we will be in Octane, so you could see what's the actual difference. Just make sure it doesn't leave any gaps. I use the geometry like this. It's some kind of a box without top and the bottom, and I put it so it intersects with my walls, but doesn't go inside. And one more important thing is that surface normals of this portal geometry should be pointing inwards. If they will point outwards, it won't work. It won't work as it should. Okay, so I think I have everything here. Oh, one more thing. I have some lamps here, as you can see, and those lamps, I want them to light something. So if you are planning to use the artificial light like this, you should consider using IES file, and this should speed up your render too, because IES files keep the rays in check, so they don't spread all over the scene, thus they produce more noise and render times get longer. So I will show you how to assign the AES files while we will be in Octane. Important thing is that to benefit from the AES files, your light source should be very small surface, like 1 centimeter per 1 centimeter, and of course the normals should point in the direction that you want to send the light. And for every bulb, you can see I created one source, and it's even rotated slightly so it looks more realistic. I didn't touch the material for the bulb itself, but it probably should be illuminated, but without casting illumination, so it doesn't create noise, only looks like it's lit. Okay, so I think that's it. That is all that we need to do in here, and you can probably do everything I did here in your 3D application, whether it's a Blender, Cinema, 3ds Max, whatever. This is some standard procedures, and those materials that you can see here, it doesn't matter how they look like, because we will tweak them in the Octane, which is easier and more fun than doing it in the plugin, because you can use nodes for example, and so it's a basic standard basic material, white diffuse material. Important is that it should have the unique name and is assigned to every geometry. Okay, so let me just export this to the OBJ file. Okay, you can see how my options are configured here. Save, yes. Or Rhino, I use some NURB surfaces, so Rhino asks me to make them polygons, so click OK. Okay, and now let's get into the Octane standalone. Now these are some nodes that I created earlier to save time, so don't worry about them. I will tell you everything you need to know. Now, to import your geometry, actually before you import your geometry, have a look at the preferences, and here is this tab called import, and if I'm importing OBJ files, so make sure that your length unit is the same that you used in your 3D application, because if it's lower or bigger, you will have some issues. In general, you will have your apartment or your interior 10 times bigger than you should, or 100 times bigger than it should be, and this causes problems. So those units should be the same. I think polygon winding order counterclockwise doesn't matter, it's a default value. Make this object layers, make sure it's height pin in height pin mode. Other settings create some additional modes, we don't need them right now, and everything here you see is as it was at the default settings. Okay, so create the node called geometry mesh, and here's my scene. So I open it. I have to refresh it, I believe, and you can see it's alright. Here is my chair. Alright, so you should see here's this option toggled, means that whenever I click the geometry, it switches to the geometry regardless the actual render target. And first thing you should do is to set up your camera to some nice view, and mine looks like this. Now you should probably create some render target to make things easier for yourself. So if you create it, then I will just plug in my test scene. Okay, hit render, and first everything, let me just turn this off. Now the image is The image is black because there's no light is there's no way the light could get in. So what I need to do is select my portal material, and it's diffuse. Everything is diffuse material, so I have to make it actually actual portal, and I just disable it for now. And as you have seen before, this is the bad settings and bad light map. This is the good settings and good light map. Now the default settings for Rhino is to use texture environment, and for the texture you probably have white color, or maybe you are using daylight. Anyway, the best way to, of course, to light the scene is to use light map or HDRI map file. While doing the interior rendering, you should consider three major factors, and that is render time, render quality, and lighting. And for the lighting, of course, lighting is the most important thing, because in general it creates render time and is responsible for the quality. So it's most important thing, and the best way to lead the scene is to use the HDRI file or the light map. Now you may ask why is that, and that's because first of all you have just one file. It's very easy to use. You can find many HDRI maps on the internet, so actually it's very low effort to find something. And the most important thing for me at least is that those HDRI files can give you very nice natural looking lighting with subtleties in colors, and this looks much more realistic than if you set up like this. You can see this looks like we're on the water or something like this. Everything is muddy, gloomy. And let me just show you one source for light maps, and it's this site called HDR Labs, and hdrlabs.com. and if you go to the smart IBL in the menu and as IBL archive, every thumbnail you see here is separate light map, and it comes with two versions. One is blurry, one is pretty sharp. Well, the idea behind this is that the blurry is used for lighting, the sharp is used for reflection, and there's as you can see, there is a JPEG file which is slightly bigger. It's 8,000 pixels wide, and it's used for visual background or for the backdrop. Now I'm just using the sharp versions for lighting. It doesn't make such a big difference between blurry one and the sharp one. And they are around 2,000 to 3,000 pixels wide, and you may think that it's not enough, but it's perfectly enough, because you won't use those maps for visual background. You can use the JPEG, which is the spherical panorama, or you can create your own backdrop or geometry, or you can add the visual background in the post process, so it doesn't matter. Now you can download, I encourage you to download them all and test these maps for yourself, because the truth is that light maps can come with very different forms and shapes. And what I mean by this is, some generates more noise, as you can see here, and some generates less noise. So you can basically divide the light maps into two groups, the bad ones and the good ones. So the bad ones you should get rid of, and you should keep the good ones. Let me just show you in this very default path tracing kernel. Everything here is as it is when you create one, and on top of that I will load the map that I think is bad with the default setting of scores. Let me just plug that in. Okay, as you can see, it doesn't look too promising, and it's basically this. We'll get to this. I don't need, first of all, we don't need 16,000 samples. You already know it doesn't look good, so max samples, just lower it to like 1024. And I have already some camera. I set up this nice view with my camera, so you can do the same. I just group it so it doesn't take this space here. Anyway, now as you can see, the map makes huge difference. Only the light map. Now let me show you what will happen if I have here the light map that I think is a good one. I plug it in. We can instantly get much nicer results, and as you can see, well, we can actually see what is in our interior and not this horrible noise. Now, of course, you could fight with that noise, you could tweak your map, and in the end you could achieve some acceptable results maybe, but the end line is that in general, if you see something like this, it means the renders will be longer and it will be harder to get something noise free. What we are aiming for is lowest level of noise that is possible to achieve, and there's some tricks to accomplish that. I will show you how. So first thing, and I think most important, is to find good light map. Now every light map, as I said before, can come with different forms and sizes and shapes, and this comes to the two settings that are most important, which is gamma and power of the environment, not of the map itself, so keep that in mind. So the gamma basically is how much contrast is in the light map itself. As you can see here, now this map is pretty contrast right now, and when I lower the gamma, I'm lowering the contrast, so the black areas are lighter and the bright areas gets darker. So this means that though this area here, when the gamma was set to 2.2, was black and it didn't lit the scene too much, so we had more noise, and most of the light comes from the bright parts. When we lower the gamma for let's say 1, for example, this parts already starts to lit our scene, so we get more uniform lighting, and on top of that, the dark areas get more light and the noise vanishes quicker. So first thing you need to do, probably every time you load the light map, is to lower the gamma. What level of the gamma to set, you have to try. For every light map it will be something different, so you have to give the slider a spin and find for yourself. Now, as you could see, lowering the gamma also lowers the intensity of the whole map, so we can compensate that by cranking up the power slider and use the power for the environment, not for the map itself, because this one is limited to 1. And let me just type in like 5, and as you can see, I already get pretty decent image with only two settings changed. Now what I'm using now is the render region tool. I think it's a great tool that it does what it says. It renders image only in the assigned region, but it works a little bit different than in version 2, because in version 2 the area inside that region rendered only up to this limit of maximum samples, and in version 3 it renders beyond that. I don't know if it renders infinitely, but as you can see now, I have in this square, in this rectangle, I have 5,000 samples, and it goes on. And it is a great tool to denoise the areas that have more noise, like this dark corner. So when your image is rendered and it's finished rendering, you can denoise the areas that are noisier. I think this is a great tool. I use the render region tool all the time to quickly preview the areas that I'm interested in, and it's just, I spend lot of time just for watching how the noise disappears. It's like my obsession. Okay, never mind. Great tool, use it very often, it will speed up your workflow. Now, another thing you can do with your light map is to, of course, rotate it to find another lighting mode, and there's a y-axis, which is the vertical axis. You can rotate the world around that axis by using the slider. As you can see, it creates different moods just by rotating. We're in the region tool, just by rotating this slider. And if you feel lucky, you can rotate other sliders, maybe you can achieve some nice effects. Just remember that what you see behind the window is not relevant, because you will replace that with your actual background. And you can go already to the kernel, and if you check the alpha channel, you can export your scene, and you have already the let's say PNG file with transparency, and you don't have to cut anything out. You have this already prepared for your background placement. Now I just uncheck it, so it looks a little bit nicer in the frame buffer for the moment that we are working on it. And as you can see, we can rotate to find the lighting that suits or that you like the most. Well, I think that this one with that yellow beam here looks very nice for me. Maybe let me rotate it just a little bit. Okay, now it's okay. Marriott, never mind. So if you're satisfied with overall look of the light map, let's just move on with the most important part of the Octane settings, which is the path tracing settings. Now the kernel itself has 4 modes you can use, and those are path tracing, PMC, info channel, kernel, direct lighting. Now let me just use another node here. This is direct lighting with ambient occlusion. As you can see, it renders much faster, but it doesn't give you the so realistic results. Sometimes you can use it with a great result, but I usually use path tracing, and that's because the PMC, even if it said it's the most realistic mode, but I never had the patience to wait for it to render clear of the noise, so I can compare. I think the path tracing is the best option. It's the compromise between quality and speed. Now there is also this thing called info channel kernel, and it's a great tool to use it while you're setting up your camera, because as you can see, it updates pretty quickly. So you can set up your camera using this. If your scene is complex or renders slowly, you can set up your camera much faster with this. So as I said before, we will use now path tracing kernel, and let me just pause it. Now there are some couple of settings that we can change to make better image. First of all, the max samples, of course, it's pretty obvious, and I think you already know what it does. It doesn't restart the rendering, so you can change it on the fly, and that's okay. Diffuse depth is basically how many times the light bounces around your scene. So 8 is too much for me, and it's the higher the value, the slower the render, so set it to 4 and this will be sufficient. If you need more light, you can make it higher, but keep in mind that something above 16, it's not necessary. You won't see much improvement, only your scene will get totally washed out because too much light is coming into the scene. And the manual says that the settings like 32 would be unrealistic, because in real life the light bounces only 16 times. Anyway, 4 is totally fine, 5, 6, I think 8 is an extreme condition for me, so I'll leave it at 4. Next setting we have specular depth. It's basically how many times the reflection ray bounces from one surface to another, and how many times that the ray can get through the specular or glass material. And so if you have 10 glasses in a row, you need like 20 specular depth, but higher the value, longer the render, slower the render. So I keep it at 4 usually, unless I need it specifically, and I will show you when, to crank it up, let's say like 6 or 7, just my glass or objects won't appear black. Now ray epsilon, you don't have to use it until you see some weird artifacts between tight spaces. I don't know exactly what's the technology behind it, but if you see some dark stripes in tight spaces, just lower this value. I can even lower it now because I have every tile as a separate object and I get dark lines here. So, and it's only visible from up close because it's so tiny. Anyway, it doesn't have any influence on the render speed, so you can lower it safely. Filter size basically is the anti-aliasing filter, and 1.2 I think is the best value. If you set it to 1, which is the lowest option, you may experience some sharp edges, which is not good. Caustic blur, well, you can leave it at the default value. If you make it higher, it will blur the caustic as it says, and thus making the hot pixels or fireflies disappear quicker. But we don't need to change the settings because we can change the GI clamp. GI clamp is a very useful and very powerful setting, and for a start we can lower it to 20, and it helps reduce the noise much quicker, and also very efficiently reduces the fireflies. So keep it low, as low as possible, but keep in mind that lower settings make your scene a little bit darker because the GI clamp does what it says. It clamps the global illumination, thus lighting gets darker, and you will see what I mean by this in a moment. Now, path termination power. Well, the manual says that it shortens the rays, and the higher the value, the shorter the rays, so they don't reach these dark areas. Thus those areas have more noise, which is not what we want. And this option should speed up your render, but I didn't see some significant difference, so I always keep it at 0. And sometimes if you use reflective surfaces and this setting is a little bit higher, then you can experience some weird noise, which is very hard to get rid of. So keep this at 0 and you'll be fine. Coherent ratio, I don't know what's the technology behind this, but I keep it at 1.2 or 1.3, I mean 0.3 or 0.2, and it makes scene flicker a little bit at the beginning. So the higher the settings, you need more samples to get rid of that artifact. You will see what I mean in just a bit. It speeds the render up a bit, so I think 0.3 is the best value for start. Now, parallel samples and maximum type samples, those two settings are not present at the version 2 of Octane, so if you're using version 2 you can skip this part. Now, parallel samples, what manual says is that it states how many rays can be shot at the same time. Now, I once set it to 16 and it crashed the Octane, so I keep it like 12. I didn't see some much improvement in speed, but the manual says it depends on the scene itself, so maybe it works better if your scene is pretty more complicated. This one is pretty simple actually. And the next one, settings, max type samples. I always keep it at the maximum level because it speeds the render quite a bit, and what it does is that it states how many samples can be rendered per pixel in the memory before it's painted in the frame buffer. And you will see it in the stripe that the darker gray stripe is moving forward, which means the rendering is done in the memory, and then the brighter is catching up, and that's the moment when the frame buffer is updating. So it speeds up render quite a bit, so keep it always at the maximum level. It's what the manual says is that also parallel samples and also max tile samples uses more memory, but I didn't see some significant difference. And I think these are all settings that you should change in the path tracing. Now let's just move to the imager node, and there's a couple of things that are here and I never touch, which is exposure and gamma. I never touch them because first of all they can make the noise that is low contrast can make that noise more visible, so they actually destroy your image. And the second reason is that if you mess with those settings, they don't restart the render, they just work like a post process. So you can introduce some clipping and you can make problems for yourself, for your image in the future. So there's actually no reason to touch this, because you can do your color grading and saturation and exposure and everything in the post process. You can just save your file as a 32-bit AXR file, and you can do things like you do with your DSLR cameras images, like in Lightroom, Camera Raw, and such a software. So don't touch exposure, don't touch gamma, it won't do any good for you. Now highlight compression, if you have some it's at default setting is 0, so I keep it at 0 if I can, but if I see some clipping or burning, you can crank it up a little bit. And as I said before, everything you can do here you can do in your post-processing application. So I think there's no need to touch this. Vignetting, of course, I keep at 0. It's at 3 at the default settings, I think, so I keep it at level 0. I can add vignetting always in the post-process. Saturation, of course, I didn't touch it. Hot pixel removal, well, this is a filter actually that removes fireflies or hot pixels in other word. And if you get this lower than 0.6, your image starts degrading, and you can see here, and it's get blurry, but the noise still is there. So if I ever touch it, if there is noise that GI clamp couldn't handle, then you can move to the hot pixel removal, but don't go lower than 0.7, because lower than that you can destroy your image. So everything else here is basically not so important. One thing is that minimum display samples, well, if you keep it at 1, the frame buffer will show your image as soon as it gets one sample. If you make it 32, you will have to wait a little bit longer, so it may come less responsive, because the Octane has to render the 32 samples before it can show you the first result. So keep it at 1 to have the most responsive experience. Well, I think that's all. Let's just see what it gave us. And this is the flickering I told you before, and that's due to coherent ratio. As you can see, 4 bounces gave us this dark area here, but what your scene looks like, of course, depends on your feeling and what you need. So I like to have some wider range of values in my renderings. Like I like some dark areas and bright areas, and this makes image more dynamic and not so boring. If you feel that this is too dark, you can make it like 5 bounces. Of course it renders slower then, but the whole image is brighter. I will leave it at 4, and maybe I will make this like 9. And as you can see, everything gets brighter. Let me just use my favorite render region tool to see what is going on there. And you can use this render region tool to calculate how many samples you need to get rid of the noise. Let's say if I mark this area, I can see that at 8,000 samples the noise is actually not visible, so I can set my max samples to value to 8,000, and that should be okay. Now let me just play a little bit because I like it. Very nice. And this image looks very nice already. There is one very useful feature which is called white balance picker, and if you pick the yellow, your image gets blue, and if you click the blue area, your image gets yellow. That's how white balancing works. So click in the neutral color, neutral gray, to get the most neutral realistic, and the idea behind this is to compensate the colors of your light map. So some light map can come with blue tone or in the yellow tint or red, so you can compensate that by using this tool. And you can even, of course, you can white balance your image in the post process, but I like to work already with white balance image, so I can assign my colors and materials in the proper way. So you can click everywhere you want to set the mood of the whole scene, and if you need this to be this blue, you can do it. I think it looks nice when it is a little bit of blue and a little bit of yellow, so warm and cool mix of colors. Or actually I should say warm and cool colors mix. Let me find some. I think this is okay. This is a little bit blue and this is a little bit yellow. Okay. Now if you want to have this light stronger, you just have to crank up the gamma, which is more contrast, which is making the light map more contrasting. So I make it like 1.3. As you can see, we can see now see this frame here, so it's more dynamic, I think. Okay, I think it looks okay. Now this already looks okay. Everything is white except for the portal. Now let me just activate the portal. You can see now I'm hitting 20 mega samples per second, and this image will be rendered in 37 seconds, something like that. It's 1024 by 512 pixels per second. It's 1024 pixels by 512 pixels. So not so big, but I think the result is acceptable. And let me just show you what happens when I enable the portal. Well, as the manual says, these settings should reduce the noise a little bit quicker, and you can see I'm hitting 18 mega samples per second, so 2 samples less than before. Now we had 37 seconds because I used the render region tool, and then the timer stops, I believe. So that was the 7 seconds I used for rendering in the region. Now there is actually no difference in the time. Maybe there is a difference in the noise level, so you should just render 2 images and compare them, and you will see if it's worth the 2 mega samples. It depends on the scene. Some scenes may benefit from the settings, and I think this is not using its potential, so I uncheck it because I like those 2 mega samples more to have to my disposal. Now let me show you just another one. Let me show you one more thing. If you want to light your scene with those lamps, first of all you have to turn off the lights outside and I have the material here that I use for the light for the light source. So let me show you how to create one and how to assign the ES lights. So what you need to do is to create the materials. Let me just pause this. Diffuse material. Now this settings doesn't matter, just go to emission and choose the black body, and for the texture choose grayscale image. This is my IES files. Open it. Now let me show you what is going on. I have to connect it to lighting. Alright, and another thing is the projection. You should use the XYZ to UVW, and for the coordinate space use normal space. And that's basically it. Let's say you can lower the power. It's too much, I think it's too bright, this light. Okay, let's use 5. When you're using black body, you have the temperature slider, so lower temperature means more warmer color, so usually you have some warm lights in the living area. Now if you check the surface brightness, actually you can play with those settings and see what those settings do. What's important is that sampling rate works best if you have more than one light source or more than one material that is used as a light source. So if you have, let's say for example I have a lamp over here, so this slider will determine where to put more samples, more or less. So if you have 100 light sources, you can specify which lamp gets more samples to render using this slider. So if you set those lamps, let's say for example for on 10,000 sampling rate, this light will get more samples to render and others will get less, which means they can create some noise, but that's not the problem, because as you can see, if you when you set it to 0, it doesn't get any light sampling rate, which is not what we want. It doesn't have too much or none influence on the render speed, so leave it at some positive value, I mean bigger than 0. That's what I wanted to say. And now, as you can see, why the GI clamp is so important, because if you set it to a higher value, you may start to see the fireflies or hot pixels, little bastards. Now if you slam this slider like to 1, those little bastards vanish completely, and you have pretty clean image lit by artificial light, which was for me was always a nightmare, and now it looks great even in this dark corner. I don't know who or what sits there. You can, as you can see, it renders pretty quickly now. You can crank up maybe the bounces a bit to see who is there. No one. Alright. One more thing. I usually, to speed up the render, I usually don't use the glass in my windows, because this can slow your render down, because there's reflection, transparency, etc. So, and in the daylight scheme, it doesn't matter as much as in the night shots. So, but I have my portal here, so I can fake the glass in the windows, because if you use specular material, it slows a bit. The render slows a bit, and you can fake this simply using glossy material. Just make it black, index of refraction to 8, roughness to 0, specular to 1, and you can see I'm having the reflection. Of course it's too strong, so you can lower the opacity if you want to see what's behind. You have some night background, what you want. If you want to show from behind this glass, then you can lower the opacity. or you can just if you don't want anything to be seen from behind this glass, you can lower the index of refraction or the specular. Then you don't have to calculate the transparency and you can save some samples. So there we have some night shot with reflections and everything, and the ES lights works okay. So that's basically it. So let me just revert, and I don't want it light shot anymore. I want it to be like this. So I think that would be all. Now I will add some materials, and I will show you one trick that I use. And let me just start with that. I use the material picker tool just to get this fabric material. Now, how to create a good fabric material? Let me just show it here. I will create the material and mix. You have to create the mixed material. Both materials should be diffused, since your fabric is not glossy, or if you want your fabric to be glossy, you can use glossy material. I will use diffused material. And for the mixing formula we will use fall of map. And what's important is that one material is your base color. I believe this is the second one. Let me just plug this to the proper ball. Now every dot you see here is the material that you assigned in your 3D application, and this way you have this one node, which is this whole geometry, and you can separate the objects by using this, by assigning those materials, or by defining them here. Now if you would like to if you would like to have some more flexibility and move this one object or another in some other place, you would have to export every object separately, and then maybe move them via transform node. Of course you have to import them into the okay, so let me just plug this into this sofa. Here's the sofa, and also to the chair. Now you can see how I can benefit from the node system. I can apply one material to objects without everything I change in one material will also apply to my every object that I assigned. I can assign it to however I want. So even though I assign the materials in my 3D app, I can change it in the Octane, and this is flexibility that's come in handy at some cases. Now sorry, now let me just change this. I want this sofa to be darkly gray, and this is the look I'm aiming for, and this is typical Fernal look, that the rim material is brighter, make it white. And let me just crank up this fall of skew factor. Now those settings may have, I believe they have different names in Octane 2, but they work exactly the same way. Now let me just crank it. Now you see it looks like some soft plushy material, I don't know, but you can apply it at every fabric, to every fabric you use in your scene. It will look much better than this. Let's say if you make this like this is flat and boring, this look cool. Okay, so I will I think we have that is all I wanted to say to you in this tutorial. Now I will add some materials and play with the scene. You can watch it to see what can I achieve from the scene, what can I squeeze from this scene. So I will start with these glasses, these vases. I want them to be glass. Now everything here is okay. As you can see, I get some dark areas, which means I need to crank up the specular depth a bit. Okay, now the table, I want this to be glossy, let's say some cool color, black maybe, I don't know. I think it looks okay if it's white. And add a little bit of roughness, so because there's no perfect materials in the real world. This would be, this is chrome, so I make it chrome. Yep. So this is chrome, this is chrome, this is glossy. Oh, here is my chair. This will be yellowish, yellow, dirty yellow, like this, and maybe, nope. Whoa. Okay, it's okay. I think it's too well. It's too glossy. What to do? I think we should lower the index of refraction. Yes. Don't make everything super shiny. It looks unrealistic. And many times I see the renders and images and everything is so shiny it looks unrealistic. And if something is reflective, the form gets lost. So because the light can't lit it properly. So just make it. Keep in mind that matte surfaces like those here and here will get lit much better and show their form much better than this one or this one. And I don't like this glossiness, so just a little bit. Now let me just, yeah, glossy black. Okay, so I think we basically, okay, I want this wall to be that orange. Now the light is hitting this wall and is making everything orange, and that's what I want. Now as you can see, I just assigned some materials and maybe the overall lighting mode changed in my scene, so I can, for example, make it a little bit brighter, even more brighter. Maybe this was too much, and I can adjust my scene to compensate these materials because it gets darker, so it's not, everything is not white, so it gets darker, so I have to crank this up. Now one more thing I need to change, and this is the floor. Floor has to be glossy, maybe like this. Okay, let's leave it. Oh, and one more thing, lamps, black. Now I could have one black material and assign it to more than one object, but this way I have everything organized. So maybe I have two black, the same materials like this and this, but it doesn't matter. So what we have here, diffuse, white, beam. Beam would be gray. Great would be great if it would be gray. Two shades only of gray. Okay. Pipes, glossy red. Those are pipes that firefighters use to extinguish fire. Okay. So that's basically it. Now one more thing. Yes, one more thing. I have here this group of environments that I chose to show you how you can quickly change the mood of your scene just by changing the environment map. Well, where is my GI clamp? I want it to be like 15. I get more bounces. Now let me show you what happened with if I crank this, if I slam this down. You see the GI is clamped. So keep that in mind. If something is dark, maybe this GA clamp, you can make it higher. a little bit higher. Alright, so I can white balance it so I don't like this purple tint like this. Anyway, so my favorite render region tool in action. Now you may like this burning area or not. If you don't like it, you can go to the imager and see what happens if you use highlight compression. But as I said before, you can easily do it in the post process, and it works just fine over there. Yep, another environment. There's a couple of seconds to get rid of noise. Now this darker gray stripe is the memory rendering, and now it jumps to the brighter one, catches up, and the frame buffers gets updated. Now as you can see, I get some dark sharp edges here on the glass, so I can use my render region to work on that area specifically. Yes, there is one material I would like to change to black, those little guys here. Okay, let's change the environment light map. Yes, this one's blue. I don't want it to be that blue. Okay, now it's okay. Okay. Well, how much noise and how quickly it vanishes, it mostly depends on the light map you use, so it's up to you if you want to wait longer, but you like the lighting so much that you can wait longer to get rid of the noise. It's up to you, as I said. Now I think on this setup, I think this couch, for example, is too bright, so I want it darker, as the rest in peace Leonard Cohen said, or sang. I want it darker, and that's it. I think this is everything I wanted to tell you. So thanks for watching. If you have any questions, post them in the comments, and stay tuned for next tutorial. Bye bye.